I'm Anil Kumar, and here is a very interesting video on reciprocal functions. We are going to understand reciprocal of a quadratic function which does not have any restriction on its domain. The question here is, determine the domain and range, intercepts, positive negative intervals, and intervals of increase and decrease for reciprocal of f of x equals to minus x plus 1 whole square minus 1. Right? So I've listed all these characteristics on the side. You need to complete this kind of table. Right? So I'd like you to pause the video, sketch the graph of the function and its reciprocal, and then write down domain, range, x-intercept, y-intercept, positive negative intervals, increasing decreasing intervals for the reciprocal function. Right? This is how I will do it. So let me first sketch the function itself. The function is f of x equals to minus x plus 1 whole square minus 1. Now in this function it is a parabola which opens downward. Vertex is at minus 1 minus 1. That means the whole function is actually opening downwards, and since the vertex is at minus 1 minus 1, it is in quadrant 3 and 4. So let us try to sketch this function first. So we will sketch first the function f of x equals to this, where the vertex is at minus 1 minus 1 and the steps are 1, 3, 5, 7 going downwards. So let us say this is our unit. Okay, so in that case minus 1 minus 1 will be a point here. Now since we are going in steps of 1, 3, 5, 7, so one step down, if I write x as 0, I will get minus 2. So that's the second point. And from the symmetry, at x equals to minus 2, I expect a value here. Then the next step, we'll go 3 down. So we'll go from here 1, 2, and let's say this is 3 down. And let us say this will be minus. If I write minus 2 minus 3, I get minus 5, correct? So that should be minus 5 for us, and the value is kind of here. Okay, and from the symmetry we can see the values here. So I can actually graph the parabola in this fashion. So that is the parabola f of x. So this is our function. Let me write down here f of x equals to minus x plus 1 whole square minus 1. I hope you understand how I have sketched it, right? I started with the vertex, okay, which is at minus 1 minus 1, and then we took steps of minus times 1, 3, 5, 7, correct? So that is how we got it. Now as you can see, since there are no x-intercepts for the function, the reciprocal of this function will not have any vertical asymptotes, correct? So now let us draw the reciprocal of 1 over x. That is, I will say r of x is equals to 1 over f of x. Now what is the reciprocal of 1? Reciprocal of 1 is 1. What is the reciprocal of minus 2? It is minus half, so it will be kind of here. And from symmetry we can say this side it is here, correct? What is the reciprocal of minus 5? 1 over minus 5, correct? So that will be very close to x-axis. So what you notice here is that we'll get a graph which will be kind of like this. That is the kind of graph. If I have to really show it much bigger graph, it will be like, if this is your axis, I mean the horizontal axis, then the graph really is kind of like this. Do you understand? So what we see here is that the graph has a maximum value of 1, right? And the minimum value is approaching 0, so it is never 0, correct? So that is how the graph of the reciprocal function is. Now once we have this graph, then we can write down all the characteristics. As you can see, the domain is all real numbers, correct? So domain for this is x belongs to real numbers. There are no, we are talking about characteristics of the reciprocal function. Okay, so the domain here is set of all real numbers, since there is no vertical asymptote. Range, however, is y belongs to real numbers, but y is between 0 and 1, where it does not include 0. So that is very important. I should write y here, but it includes -1, right? So this is -1. So the range is between 0 to -1, where -1 is included, but 0 is not included. Does it have any x-intercept? No. So none, right? So no x-intercept. How about the y-intercept? The y-intercept is 0, -2. Positive. We are saying positive interval. So the graph is never positive, right? It's always negative, right? How about negative? It is all along its domain. So it is all along its domain. It is negative. Is it okay? Increasing. You will see it is increasing from -infinity to -1. So we'll say interval for increasing is from -infinity to -1. And interval of decreasing is thereafter it is decreasing, right? I'm sorry. It is actually decreasing in this interval. I'm sorry. Increasing means going downwards is decreasing, right? So it is increasing in the interval from -1 to +infinity, and it is decreasing from -infinity to -1, right? So it is decreasing, going downwards, right? So that is how the characteristics of the reciprocal of this quadratic function can be defined. Go through this video and try to understand and appreciate that there are instances when reciprocal of a quadratic function may have a domain without any restriction. Do you understand? And it could have absolute maximum or absolute minimum, correct? So in this case, we have an absolute minimum value. Therefore, we have a range which includes -1, but it approaches 0, right? So that is how we can actually describe our reciprocal function for the given quadratic function. I hope that helps. Thank you.